The formula to calculate your the amount of time each time constant is the inductance divided by the resistance. Everybody have this copied down? Picture taken, whatever. Alright, so in this circuit we have a 10 millihenry inductor and a 20 ohm resistor. Alright, so how long is it going to take for the current to reach the maximum value? Alright, so our first step, we got to figure out how long one time constant is. Alright, so one time constant is going to be a half of a millisecond. Alright, so the amount of time it's going to take to get to our maximum value is 5 time constants. It's 5 times 0.5 milliseconds. It'll be 2.5 milliseconds to reach maximum current. Y'all good with that?
I'm not, maybe I missed something. Why did you turn it into .01?
So it's in millihenries.
Yeah. Okay.
Just convert that into henries. Y'all know how to convert from milli and micro to the base, right?
Yeah, I just wasn't paying attention.
1
1
millisecond.
milliseconds? Because that's what we come out to.
I know, but I mean like, you're doing time.
So I'll whatever our time is in seconds, right?
Okay. So
I put it in 0.5 milliseconds rather than 0.00005 seconds. Just it looks better than all those zeros.
You know what? How do you convert it from millihenries to
Okay, easy. Alright, so everybody watching?
Yeah.
Everybody watching. Alright. So we've got 10 millihenries. Alright, so we know way back in high school that there's an understood decimal right here, right? Alright, so milli is 10 to the minus 3. Okay? So, if it's 10 to the minus 3, we're going to move to the left 3 spaces.
Yep.
What? Who knows what that is?
Micro.
It's micro. What is it?
Six.
Uh-huh. No.
9.
Is it minus 9?
Twelve.
Pico.
Pico.
That's to the negative 12.
Uh-huh. When we're doing inductors, mainly going to say milli. We have millihenries and henries, main thing. You might say a few micros, but the majority is these. When we get into capacitors, you'll see all three of these. Okay? So, very good question. You need to know, because, you know, the same thing when we get to capacitors, you know, it's in farads, but, you know, it's not millifarads, microfarads, picos, it's in farads. You got to be able to convert that 42 picofarads into 0.00000042 farads. Just like when y'all started, you know, doing DC stuff last year with resistors, you know, kiloohms and all that shit. You know, unless everything's in kiloohms, you can't just put, you know, 10, you know, as the thing, right? You know, you gotta get it all in the same unit before you can do anything. Gotta be all apples or all oranges. Apples and oranges don't go together. Alright, so we good on time constants?
The PowerPoint, that's available on the ProTech Institute website.
I guess. It is on mine, I don't know if it is.
That's probably in the book, too. Somewhere.
Yeah, it comes straight from the book.
Okay.
I think chapter 3 in AC theory is what that PowerPoint was from. Without looking at your notes or phone or whatever, what is our formula for inductive reactance?
2 pi.
2 pi.
There you go. 2 pi.
Times F times L.
That's it. Okay, so what if we know our inductive reactance, we know our frequency, but we have no idea what the inductance of the coil is. How do we find that?
Henry.
It will be in henries, yeah.
Or Siemens.
Any guesses?
3.19.
No.
No.
No. So we know this one, and we know this one, right? Do not know this guy.
That bullshit out
I just solved for L.
Yeah, man, but when we got fractions back like 3rd grade.
Right, don't think of it as a fraction. Think of that as you're dividing. Yeah, that's all you're doing. That's all you're doing. All that equation is L equals X sub L divided by 2 times pi times F. Look, no fractions anywhere. Nowhere. That's how a fraction is division.
Yeah, but that's what
I mean, look at the sign for division. What does that look like? Look at 1
It's a
and
fraction.
4. Look at there. That's all it
Yeah.
is.
It's always
I
fractions.
get it's a fraction, but what I'm saying is like a subtraction. Like,
Can you divide?
no.
Well, get the fuck out.
I'm fucking with that.
Alright, so same manner here. Alright, we know our inductive reactance and we know our inductance. What is the frequency? Y'all work those 3 problems. Alright, what we get for inductive reactants in our first one?
CPS, no.
628,318.5307.
Okay. What about our inductance on the second one?
1.59.
Alright, frequency?
867.43.
No.
8,557. That's rounded up.
No.
I got 1,200.000185.
1200.
Yep.
Alright, so one of those get 800 and 700 and all that shit on the frequency. Alright, so I know what you did. Alright, so when you put in the 6408.85 divided by 6.28 times 0.85, right?
Rule of parentheses.
Need to do
Please excuse my drink, Sally.
exactly. Gotta put that parentheses in there, order operations. I know we're saying that the formula is X sub L divided by 2 pi times whatever, right? But it's divided by 2 pi times that. Not divided by 2 pi times that. See what I'm saying? That makes sense? So make sure, anytime we're doing any sort of problems on here, using your calculator, parentheses and shit on the bottom. You know, divide, then open parentheses, whatever you're doing, close parentheses, equals.
Yeah, and so I type in 10,000 for that kilo ohms. Type in 10,000. That's what I was doing. 10,000.
Yeah.
Okay, I just
Yeah. Yeah, the only time you're ever gonna just put in 10 is if it's
If you have a
everything every number in
the
there
same.
is a K or an ohm or whatever.
Yeah.
Alright, so here we have an inductor hooked up to a 120 volt, 60 hertz source. What is our total current? Any guesses on what this formula would be?
I don't know if I tuned you out or if I missed it, but I got the frequency one wrong because of the parentheses. Did I get the previous one before that wrong because of the parentheses as well?
Probably yes.
Yeah.
The same concept, just different numbers.
Okay. It's all in there. And
Alright, so what, Ohm's law. Current equals what?
P equals I times
E over R.
Okay,
E over
alright, so that's current equals volts over ohms, right? Okay, what is inductive reactance measured in?
Henry's.
No. Inductance is measured in henries. Inductive reactance
Resistant.
is measured in. What is resistance measured in? Oh.
So that will be 0.1 hertz on the first one if you're removing the milli out of the equation for
Yeah, 0.1 henries.
0.1 Henry's.
Mm-hmm. So what's our first step gonna be here?
600 Henry's.
What do we have to do first in order to find current from what we're given?
Divides.
get all apples or oranges.
No, it's not.
Well, we gotta get that henries in something we can stick into Ohm's law, right? There, if you look on that Uglies book, there ain't shit on there. It's got a fucking L in it, right? So it does zero good for us to have an inductor when we're trying to figure out current without doing something to it first. So our first step, we gotta convert this right here into inductive reactance.
$37.7.
Alright, so now what?
You can just do your E times R. Divide the 120 volts by that 37.7.
And
3.8.
I ain't telling y'all how to do shit, but I would recommend when you're doing your homework, write the fucking equations down like I do every time. I mean, that way you just write the shit, and all of a sudden you actually fucking learn something, right?
Okay.
3.183.
Alright, I'll work on the second one. we've got a 500 millihenry inductor connected to a 10 volt DC source. Y'all smell something burning? Smell them wheels turning. The what? I believe that shit.
Alright, I'm gonna say it. Alright, there's no hertz. There's no 60 hertz.
You gotta
problem.
convert the 10 volts into hertz. Just trying to figure out which one it is to do it.
No.
It's in DC.
Dustin,
It's in
you're
DC.
right.
I was sitting here looking at it like
You're right. What is the frequency of the DC circuit?
It's always, there's not.
Zero.
Zero.
It's DC.
Oh, damn.
Alright, so therefore, what is our inductive reactance?
Zero.
Zero.
So what is our current?
Zero.
No,
Off the chart.
it's infinity. Why is that?
Because it's not changing, there's no wavelength.
But, get out your calculators, put 10 divided by 0.
You're breaking the space-time continuum.
You can't. I mean, just think, how many times is 0 gonna go into 10? However the fuck many times it wants to, right? I mean, what is 0? Nothing. Uh-huh. Alright, so. Y'all go with inductive reactance.
So we won't see too many of those DC problems then, right?
No, no.
Okay.
That's just one to fuck y'all up.
Yeah, I was about to say.
Now, I really wouldn't be surprised if there's not one like that in your fucking homework, just because they're fucking dickheads. Alright, so now.
I was wondering why you wrote DC originally. I was thinking oh, DC. So,
You thought I fucked up, didn't you, Alan? You just weren't gonna say nothing.
no, I was thinking, oh, it can be done in DC. Okay. And then I forgot, oh, it can't.
Alright, so this is a triangle.
Yes. And I spelled the least triangle.
It's supposed to be a right triangle, Alan. Give me a break. Now, it is an impedance triangle. Alright, so our horizontal leg always going to be the resistive part. vertical leg is always going to be our reactive part. Our hypotenuse will be our impedance. Our angle here will tell us the phase shift between our reactance and our resistance. Alright, so in the PowerPoint, if we are given reactance and resistance, does not matter which one you use. It all depends on what you're given. Right? So if you're given reactance and resistance, you're going to use arc tan. If you're given resistance and impedance, you're going to use the arc cosine. Reactance and impedance, you're going to use the arc sine. Alright, so to calculate our impedance, just like when we was adding vectors, we're going to add them vectorally. Impedance in a series circuit, the impedance is the square root of resistance squared plus the inductive reactance squared.
You said in a series circuit.
Mm-hmm. It's going to be a little bit different formula for a parallel circuit. Alright. Time constant. Alright, so that should get you through your homework, which is going to be lesson 1 in AC theory.
Just lesson 1, right?